Good morning, students. Yesterday, we discussed intensity of electric field due to an electric dipole at any point, right? Now, we try to solve some problems based on dipole, right? Here is a problem. This is a dipole and this is axis of the dipole, This is axis of the dipole, and here is a point. That point is represented with the coordinates 2, 2 root 2, 0. At this point, due to this dipole, let electric field is net electric field in this direction. Maybe in this direction, like so. What is the angle made by this electric field with the axis? What is the angle made by electric field with the axis? That is the question asked, right? See, this point the line joining the center to this point, this line, this point coordinates are 2, 2 root 2. So from these coordinates, can't we find this angle? Theta. And we know from our yesterday's discussion, here is A1. With this line, the angle made by this E is alpha. So this is theta, angle made by this line with axis. This is alpha, angle made by resultant electric field with this line. So what is the total angle made by this E with axis? Means what they are asking is total angle. What is the angle made by this total? Alpha plus theta, right? This angle is theta plus alpha is how much? This is what they are asking, right? Okay. Once these coordinates are given to you, we can write theta. Tan theta is equal to, see, this is x coordinate, this is y coordinate, this is z coordinate. Tan theta is y by x. We can write 2 root 2 by 2. And we know the relation between this alpha and this theta. Yesterday we solved it. What it is? Tan alpha is equal to half tan theta. Just go through yesterday's topic. If this is alpha, tan alpha is equal to half tan theta, right? From this, half tan theta root 2, right? What we get it? 1 by root 2. So we got tan alpha is equal to 1 by root 2. I can write this tan alpha equal to 1 by root 2, cot alpha is equal to root 2, tan alpha is equal to 1 by root 2, then cot alpha is equal to root 2, right? But cot alpha can be written as tan 90 minus alpha. Cot alpha can be written as tan 90 minus alpha, right? Which is equal to root 2. This third one. See here, tan theta is root 2, tan 90 minus alpha is equal to root 2 from 1 and 3. From 1 and 3, what you can write? Tan theta is equal to tan 90 minus alpha, right? So on both sides, remove tan, we can write theta is equal to 90 minus alpha. Bring alpha on this side, theta plus alpha is equal to 90. What is this theta plus alpha? Angle made by the resultant E with axis, right? So angle made by resultant E with axis of dipole is 90 degrees, right? This is the problem as per in previous sentence. Important model. They give this theta and they ask this alpha. Once theta is given to you, you can write alpha. Tan alpha is equal to half tan theta. Then alpha is equal to tan inverse of like that. So on this model, you get so many problems in entrance, right? Come on, note down. Next. Now this is a dipole. This is a dipole. See, just here I am representing with an arrow, means here is minus charge, here is plus charge. This is a dipole. This is center of the dipole, and at this point, the field direction is like this. Field direction. That field direction, see, you are given in the problem with the line joining the center to the point with this line, this net electric field making some angle. That angle is given to you, let us say some pi by 3. Some angle given to you. What is the sentence they used? The angle made by resultant field E with line joining center O to the point C. The angle made by the resultant field E with line joining O and the point C is alpha. That alpha is given to you as pi by 3. Generally, the problems, the sentence comes like this. What question they ask? What is theta? What is theta? What is theta there? That is the angle made by this line with angle made by the line joining O and C with axis, right? What is that theta? You have a relation. Tan alpha is equal to half tan theta. Tan alpha is equal to half tan theta. Alpha is pi by 3. Tan of pi by 3 is equal to half tan theta. Right? Assign the values to get the answer. So tan theta is equal to 2 tan pi by 3. Theta is equal to tan inverse of 2 tan pi by 3. Assign the values of tan pi by 3. You get the answer. Like they ask the relation between theta and alpha. By giving theta, they ask alpha, or by giving alpha, they ask theta, or by giving theta, they ask what is alpha plus theta. Whatever we discussed in previous problem. Right? Come on, note down. If you want, you can write tan pi by 3 value also. Tan 60. Root 3. Even you take it to root 3 there. This is also the problem asked in previous entrance. Next. Here is the dipole. This is a dipole. This dipole, this is a point. Where the point is on the axis. When this is a dipole, minus q plus q. I am choosing a point here where this point is on the axis. At a distance r. At a distance r. Right? Here the field is given as E. The field is given as E. Right? The question asked is when dipole turn it is turn through an angle 90. turn through an angle 90 degrees at same place at same point C. At the same point C, what is the intensity? What is the intensity? This is the question asked. At the same point, whenever it is turned, what happens? The dipole becomes like this. Initially, it was like this. If I turn, this is the dipole position. This is the center, not changed. From the center, point is here. C, distance not changed. Same distance R. What changed here? Now this point comes on equatorial line of this dipole. Equatorial line of this dipole. Then what happens to the field here? E dash becomes E equatorial. E equatorial, E axial by 2. Sorry, E, right? E axial by 2. E equatorial, we know the formulas. E equatorial and E axial. The relation between E equatorial and E axial is E equatorial is equal to E axial by 2. Here, where is the point? This is on E axial, right? So what is the answer? E dash is equal to E by 2. Right? This is the answer. So what is the question? Dipole is initially like this, such that point is on axial line. Dipole turned through 90 from its position. Turned through 90 from its position. Then at the same point C, what is the intensity? E by 2, right? Next, in the same case, how the direction between this E dash and this E, how they are, right? What is the direction of this E dash? If any dipole, if you represent with arrow like this arrow is the dipole moment direction, right? Once this point is on equatorial line, what is the direction of the intensity at this point E dash? Opposite to the dipole moment. This is E dash direction, right? E dash direction. Here, E direction is this. Sometimes they ask you, how this E dash with this E dash and E are perpendicular. E dash and E are perpendicular, right? Next, this is one dipole and this is another dipole. Combination of dipoles. This is one dipole and this is another dipole. Its dipole moment is P1, its dipole moment is P2. Means for this charge is here plus charge, minus charge, plus charge. Here minus charge, here is plus charge. Like this. Let dipole moment of this one is P1, dipole moment of this one is P2. Let I am taking one point here. The C is a point which is at a distance R1 from this first one. From the center of this, it is at a distance R2. It is at a distance R2. Then at the point C, what is the resultant intensity of electric field? So two dipoles, this is one dipole and this is another dipole. At this point C, what is the resultant intensity? Right? Come on. We know for this dipole, it comes on axial line, right? This point comes on axial line for this dipole. So what is the field direction? Can I write like this? Due to this dipole, this is field direction. It is along the dipole moment. Clear? For this dipole, what is the field direction? Field direction is opposite to the dipole moment. Opposite to the dipole moment. If dipole moment is in this direction, this is in this direction, right? So here, E1 in this direction, E2 is in this direction. Dipole moment is in this direction. As it comes on to its equatorial line, it is anti-parallel, right? Non-collinear E2. So they are perpendicular. Then what is the resultant? Then resultant E root over E1 square plus E2 square. Right? What is E1? Due to this dipole. Due to this dipole. What is the formula? 1 by 4 pi epsilon naught axial 2p1 by r1 cube. What is E2? Due to this dipole, for this dipole, this point is on equatorial line. 1 by 4 pi epsilon naught p2 by r2 cube. Right? This is the way of doing. See, this is one example. They may give different combinations. 2 dipoles, 3 dipoles, like different combinations they give in the exam. Right? The procedure is what? Where that point comes for the dipoles, you just draw the directions of the intensities. Accordingly, you take the resultant. You will get the answer. Right? Come on. Note down or take a screenshot. Next, different combinations I am giving you. You try those. This is one dipole. This is another dipole. Let dipole moments are same. This is a point at the same distance from. What is the intensity here? At this point, what is the intensity? Second, this is one dipole. This is another dipole. This is another dipole. Like this. Dipole moments are same. At this point, what is the intensity? Let all are at the same distance. Are R, R only. This is asked in previous sentence. What is the intensity at this point? What is the intensity at this point? Right? This is one dipole and this is another dipole. This is another dipole. This is a point. This is a point. At the same distance. What is the intensity here? So try, right? So like two dipole combination, three dipole combination, they ask the problems. Take a screenshot and try those problems.